Okay, this is activity TT62, and it's a very limited type of finite element analysis that I'm showing you in the CAD class. Generally speaking, if you want to know finite elements, you have to take basically a theoretical course, and uh, you don't really do that in a CAD class. However, at least in this course, you're responsible for doing very simple problems on the final exam, which involves finite elements. Now, the problem that we're doing is a very long tube of these radii, 2 inch and 3 inch radii, and it's internally pressurized, say 1,000 psi. Now, this general, I mean, obviously, this is a three-dimensional problem. However, because we assume that the plane is infinitely long or very long, back in the strength of material course in your second or third year of engineering, you came across labeling this thing as a plane strain problem. In other words, we can pretend that you can take a sector of this tube, and the top of the sector and the bottom of the sector does not translate perpendicular to it. That is true. So we can view the top and the bottom as being planar symmetry, as if it's in a roller condition. You can also take any sector, any angle that you want from this particular cutout. For example, 90 degree, 45 degrees, 30 degrees, and the plane that you get by taking that sector on both sides, they're also moving only radially out. That means that they're roller, basically on rollers or surface slider. So the bottom line is that this is the geometry that you have to model. 2 inch inside radius, 3 inch outside radius. The height of it is totally immaterial. We can take it about maybe 2, 3 inches. I'll take it 2 inches, and then these are surface sliders, and then you put the pressure on the inside. Very simple. Okay. So let's go ahead to Catia. Start with the part file, and I'm going to call this thing a TT62. Okay, let's make it. On that horizontal plane, I build a sketch. Okay. All the sketch, let's take a 90-degree sector. Although you can even take a 45, any angle you can take, but I'll take a 90-degree sector. Okay. It's easier for me to draw that. Here's one. Here's another one for the inside, for example. And then we dimension these things. So this outside one is 3. This is the inside one, which is, let me do the outside one first. Let me do this. Outside one is 3 inches. The inside one is 2 inches. And in order for us to pad this thing, you have to close this thing with a line segment, for example. Incidentally, I could have drawn a rectangle and then shafted it about the vertical axis by 90 degrees. That would have been the other option. So you pad it. We decided that the height of this thing is 2 inches. Okay, good. Apply material on it. I think I said steel, but I'm not sure. So let's put steel on it. Good. If you want to analyze aluminum, go put aluminum. And then we're going to go to analysis and simulation, generative structure analysis. Okay. And this is the mesh. Would you, first of all, let me change the rendering here. There we are. If you want to see the mesh, you put the cursor on this line, right click mesh visualization. And if you're happy with it, just let it be. So I'm going to uncheck this. By the way, Katia will remember the last time what kind of element you use. You use that. Since in TT61, the last time I used parabolic element, it used it. But if you want linear, you can just change it. Just change it. Okay? I'll leave it as parabolic. Okay, deactivate the mesh, put the cursor on this, right click, deactivate it. You can also delete it, but I don't know why. Deleting this thing is not deleting the mesh. It's just the mesh representation on the screen that's going to get deleted. It's still meshed. Okay, so let's see what else we have. Surface slider on the top, on this, on that, and the bottom. And let me remind you once again, why do you have a surface sliding on the top and the bottom? That's because we're dealing with a very long tube. This is a state of plane strain, and that means that the top and the bottom do not move much in the vertical direction. That being the case, we're going to assume that they are on roller. It's exactly what not moving means. Now these are surface slider because we took a sector of that and noticed that uh, points on these two planes will just radially move out, right? So it's basically remain on that plane. And then pressure, right there is the pressure on that internal face, 1,000. I think we said 1,000. Good. Run it. Always save your analysis in case it crashes. So file, say management. Here's the analysis. Save as. I'll put it, it's right there. I'll call this thing dash TT62. And propagate directory means put everything in there. Let's check it out to see what actually put in there in that folder. So here is the part. This is T262, the part, and this is T262 as the analysis. Remember, on the final exam, if this was the problem, you not only give us the part, you also give me the analysis file. Both of these I need. Okay, good. And pretty much that's it. Run it. Run it means compute. Remember, the sequence is like this. Model manager in case you want to do refinement, which I didn't in this case. And then there's restrain and do load. The order of these can be reversed, but anyway, you need restrain, you need load, and you need to compute. Okay? That's the way things go. And you get this message because you have roller condition on it. I don't know why they won't get rid of that. So let me see now. This should move radially out. There it is. Okay, good. If you want to know the deflections, there we are. Very tiny amount of deflection because this is 1-inch thick piece of steel and under 1000 psi, which is really not much, at least for damaging the material is concerned. Okay. Biggest displacement is on the outside. Sorry, on the inside. Yeah, on the inside, the biggest displacement, smallest displacement on the outside, and of course, pressure is going to be, well, hang in there. What is the, sorry, this was on mesostress, not displacement. Okay. Displacement is right here. There. Okay. So this is displacement in inches, and if you want to see the one mesostress, you have already done it. I've just deactivated it. Let me move this thing on the side. I'm going to deactivate this and activate one mesostress, and there we are. I don't know why I did displacements twice. One of them I don't need. I'm just going to delete. Good. Incidentally, if you want to see it as shaded like this, you double click on this legend and click on the three dots here. Let's say, don't show it to me as smooth, show it to me as basically distinct colors separated from each other. You can see that the colors are like that. Now, in the event that you want to see the elements here too, go to that rendering at the very bottom. At the very bottom, one rendering is with the question mark. It says customize view parameters. And just say show me the edges and points too. I mean, you may want to see that in case. May want to see that where are these elements, where the stresses are, etc. within the element. That's pretty much it. Good luck.